Okay, in this exercise we're just going to quickly look at natural ventilation, which in the lecture we discussed is something that you're going to need to think about in buildings, because buildings need air for a variety of reasons. So you can either bring that air in through the natural force of natural ventilation, or you can use energy to bring it through your homes with fans, etc. Okay, so we have three things I'm going to ask you to do. The first thing I just want to quickly understand is the ratio, geometrical ratio in terms of the height of your room with respect to its depth. That is important because it tells us something about the potential for natural ventilation. I told you about the project, the LSE Student Centre, where as a result of gaining a metre, just over a metre of height in that project, we were able to demonstrate a couple of things, one being the improvement in terms of daylighting. You might remember that related to the view to the sky, but critically it related to this question of whether a main space in the building could be naturally ventilated or not. And that relationship was to do with the depth of the space, shown here in plan, and the height of the space, which, as I say, became a metre higher as a function of a design change. And when that metre was added, it meant that the area which we potentially would have had difficulty naturally ventilated reduced substantially. So there's a strong relationship between that height and that depth. The reason that relationship exists is because, of course, the higher a room is, then the more potential there is for buoyancy effect. Buoyancy effect, very simply, is the effect of warm air rising above your head. When it rises, it draws cooler air in to take its place. You end up with this natural circulation of air from a low level to a high level, and that's a force which can drive natural ventilation. So I showed you this slide, but the reason this is interesting to us because it can really inform our section, particularly the relationship between our plans and our sections. So in terms of the rules of thumb that I want you to have a look at, if you have one window in your room, which probably most of you do, then if that window is a single opening, then you can say typically that the depth of that room can be around twice the height of the of that room. So a ratio of 1:2 is more or less what you could go with. You can slightly improve on that, and this is again with just windows on one side. If you have a strange arrangement of windows where you have a low level window and then a high level window, well, that further improves the buoyancy effect because effectively you're bringing air in at a low level and then allowing it, maximizing the difference between the low and the high, which then, as I said, maximizes the force. So that allows the room to be deeper, a ratio of about 1:2.5. Now, I did mention in the lecture this whole question of wind-driven ventilation, and I'll say a bit more about that in a moment, but just to say now for the moment that if you do have windows on both sides of your plan, one on one side and one on the other, then you have the potential for what's called cross ventilation, which is a far more powerful way of moving air through your building. And if you have two windows, one either side, then the ratio that you can achieve is much greater. You can achieve about a 1:5 ratio. That means if you've 3-meter tall floor to ceiling, you can have about a 15-meter depth. Now, I'm not sure how many of you are going to have 15-meter bedrooms, but see how you get on. And just to say that the difference in terms of those two driving forces is quite extreme. It is far more effective to use wind-driven than to use buoyancy, but that's not always possible. So I'll tell you about both of them. Okay, so basically that's the first thing I want you to do. It's very simple. It's an analysis of your room. And you can do that on the drawings that you've already done. I then want to take that to the next area, which is looking at the windows more closely. I would like you to document the windows that you have. You can draw them, you can photograph them, but critically I want to understand what they actually mean in terms of what we call free area. So free area is, although the window might have an area of glass, the question of how much free area, as in when it's open, how much that actually means, isn't quite as clear cut. Again, the rule of thumb is that you should have 5% of free area with respect to the room area. So What do I mean by effective opening? Well, it means if you look at this window here, although it's a big window, because it opens only to a small angle, the effective opening that you can see here, that effective opening limits actually what usefully can be called area for natural ventilation. So I want you to do the same thing for your window. There are many types of windows. Have a look at what yours is. You could have a horizontal pivot, you could have a vertical pivot, you could have a top or bottom hung, you could have a side hung casement, you could have a tilt and turn, you could have a sash sliding, you might even have louvers. Whichever you have, I would like you to very accurately measure that in terms of understanding how the window opens, and when it's at its full opening, or the one that you generally use, what actually is the effective area, and then what is the relationship of that effective area to the area of your room. Essentially, you should be looking at 5%. Have you reached 5%? That's what I want to know. Okay, last but not least, in terms of natural ventilation, I would like you to understand your whole apartment in terms of how it operates with respect to windows. One very good way to do this is empirically, simply with a little candle, just to understand what the impact of opening one window is versus opening two windows on each side. And I'd like to try and, even if you're in a room beside a corridor, just try and find a second window to work with, because it will make it much more clear when you do it. Just to remind you, my home obviously is a series of rooms, but there are opportunities for cross ventilation. But most of my rooms, that can only be ventilated through one window. It's single-sided, that also. This less so, because I can actually open one and ventilate out to the other, and of course I can open the front door and ventilate out through there. I'd like you just to test that with something very simple as, on your diagrams, show me which ones are open, show me which ones are closed, and then see what the impact is in terms of air movement through your house. You might pick a day that's just a little bit windy, just to accentuate that. And see if you can figure it out in terms of documenting where the wind is coming from and where it's going to. It's very useful to try and understand that, and it's also useful to try and bring in what I asked you to do before, which is this. I asked you to use this program, which is Autodesk Flow Design. I gave you the link for that. Now I've been playing with this. It's a fairly new program, but it shows us something which I think will be fairly intuitive when you come to doing your houses, which is with respect to the prevailing wind direction, and you will have to use this orientation button to make sure that the orientation is correct with respect to your house. And if you set this as I've set it now, and you can follow this YouTube just to match those to be exactly the same. This is what I want. I don't want the ones with all the lines, streamlines coming across. I actually want to see surface pressures, because as I said in the lecture, what matters is the difference in pressure from one side of a building to another, and that negative pressure is what sucks air out of your building. So what I'd like you to try and look at, if possible, is to see whether you can in some way understand with this tool which windows have low pressure, which windows have high pressure, and then going back to your plan, how potential connections between those two windows might be the ideal way to bring air through your building. So that's pretty much what I would like you to do.